What if we built a huge tower on the moon? A tower that could provide future missions with light, power, and guidance technologies that could help astronauts explore our natural satellite. It's not something from a sci-fi book. It's a novel idea from Honeybee Robotics, one of the brightest space technology companies. The lunar utility navigation with advanced remote sensing and autonomous beaming for energy redistribution, or simply Lunar Saber, is a 328 tall pole. It's capable of holding 1 ton of equipment on top of it. But how could we build such a giant construction? No rocket would be able to hold and land such a giant pole on the moon. And building such a tower on the lunar surface without already existing infrastructure would be next to impossible. So, Honeybee might use the deployable interlocking actuated bands for linear operations Diablo system. It uses a rolled piece of metal and bends it into a deployable cylindrical structure that can support really heavy payloads. It would be easier to build it on the moon because gravity there is only 16% of that on Earth. The structure could serve as the base for Lunar Saber. Power is crucial on the moon, so putting solar panels along the sides of the pole would be super useful. The company is now discussing 2 types of solar panels. The first one is like a yo-yo extended from the top payload holder of the tower. It would envelop the metallic structure and allow access to the sun at all angles. The second option might involve the top part of the tower. It could deploy its booms to hold traditional solar panels and then track the sun. Power supply wouldn't be the only Lunar Saber's task. It would also be able to beam power to other devices, track other devices, and provide communication, light, and energy. Let's talk about these functions in more detail. If one mast of the pole was bathing in sunlight while another was lingering in shadow, the one with excess power would be able to beam power to the one lacking it. Plus, similar power beaming could happen between Lunar Saber and rovers and astronauts in spacesuits. To beam all that power effectively, though, the tower would need to know the precise location of those objects. That's where the second technology would come in. Lunar Saber could use a set of sensors to find and track other objects. Basically, anything in a direct line of sight could be tracked and powered by the tower itself. Lunar Saber could also act as a lunar cell phone tower. It would allow wireless communication in its network. And finally, it would be super helpful for astronauts to actually see where they would be going. Rovers wouldn't need to wait out the 2-week lunar darkness. Floodlights at the top of the tower could provide enough visible light for astronauts and rovers, which would allow them to effectively perform their activities at all times. But guess what? The tower could become even more useful. We could combine several towers in a mesh. It would allow astronauts to communicate more effectively. Plus, power could be beamed even from the other side of the moon. It would enable 2 main applications that have been a thorn in lunar exploration's side so far: constant communication with Earth and constant supply of solar power. The thing is, explorations on the other side of the moon are quite tricky, which limits the area of scientific research to the side directly facing Earth. But a strategically placed mesh of Lunar Sabers could allow communication back to Earth, and we would be able to explore the dark side of the moon. Since at least half of our natural satellite is always lit up, if we placed Lunar Sabers correctly around the surface of the moon, there would always be at least one bathing in sunlight. That one sunlit tower would then wirelessly transmit power to others in its line of sight. This process would keep going until power was beamed to the main astronaut's base, supplying them with power even in the cold lunar darkness. Unfortunately, at the moment, such technologies look unrealistic. We're not close to having wireless energy transmission over long distances. Even on Earth, we still need to use batteries and wires. It might be easier to launch many satellites into orbit around the moon than to create a network of giant communication towers. Did you know that in 1958, 2 powerful rivals planned to take the lead in the space race by launching an atomic bomb at our natural satellite? What would have happened if they had gone through with it? Who the hell thinks bombing the moon is a good way to win a popularity contest? On top of that, we're going to find out if anyone ever did bomb outer space and why.
Stick around, because what we're about to tell you sounds incredible. But it actually happened, and even Carl Sagan was involved. It's not like there weren't better ways to grab attention, but let's be honest, who wouldn't want to see some space fireworks? That was pretty much the thinking behind the US Air Force's secret project, A119. This top-secret initiative aimed to launch a nuclear bomb at the moon, hoping the explosion, with enough megatons, would be visible from Earth with the naked eye. To understand why such a wild idea could even seem reasonable at the time, we need to look at the context. In the 1950s and 60s, international tensions were sky high. The aftermath of World War II and the rise of two rival superpowers, the United States and the Soviet Union, led to the Cold War and the famous space race. That race brought incredible scientific advancements: artificial satellites, robotic landers on the Moon, Venus, and Mars, the first human orbital flight, and eventually, the first moon landing in human history. But not every project launched during the space race was a win. Some were total failures, or worse, absurd and dangerous ideas that cost governments tons of money just to prove who had the bigger rocket, so to speak. Project A119 also aimed to answer some questions in planetary astronomy and astrobiology. Like what, you might ask? Well, for example, what would happen if a nuclear bomb exploded on the moon? A very original study, you have to give them that. Despite its age, it remains one of the few declassified reports on the topic. And to make this case even more interesting, young Carl Sagan was part of the team. He was responsible for predicting the effects of a nuclear explosion in vacuum and low gravity. This bold idea, to detonate an H-bomb on the moon for everyone on Earth to see, seems to have been sparked by a rumor published in the Pittsburgh Press in 1957. The article claimed the Soviet Union was planning to celebrate the anniversary of the October Revolution with a big bang on the moon. The explosion would take place at the moon's terminator, the boundary between its lit and dark sides. Apparently, Project A119 also considered the terminator as a target. The article also mentioned that if the Soviet missile missed, it would fall back to Earth and disintegrate in orbit. But what it didn't mention were the even bigger consequences if it did hit the lunar surface. But wait, what could possibly go wrong? The moon's super far away, right? Well, a lot could go wrong. It depends on the bomb's yield, of course, but what if a 100 megaton bomb exploded on the moon's surface? That would trigger a series of very unfortunate events. Since the moon has no atmosphere to dampen the blast, there would be no shockwave like on Earth. With nothing to contain or slow it down, the explosion would just keep expanding monstrously. Terrifying, right? But that's not all. The moon would experience a massive quake that could shake the entire body. Though, to be fair, back in 1958, there were no lunar bases to destroy, so that wasn't a big concern yet. The impact would pulverize the lunar surface, launching dust and debris into space in all directions, including Earth's path. Many of these micrometeorites could rain down on our planet, causing damage. While the blast on the moon wouldn't go on forever, it would eventually cool and lose energy. The leftover radioactive material would slowly settle back onto the surface. And without natural processes like Earth's rain or erosion to clean it up, the radiation would stay there for a very long time. So, what eventually happened to the US's Project A119 and the Soviet Union's Project E? Well, what had to happen? Both were scrapped due to the extreme risks and the possible impact on future lunar colonization. Now, a question some of you, especially Star Wars fans, might be wondering is, Were there no more plans to blow stuff up in space after that? And the answer is, oh yes, there were. It wasn't exactly a bomb, but in 2009, NASA deliberately set off the equivalent of about 2 tons of TNT with the LCROSS, Lunar Crater Observation and Sensing Satellite. The goal was to see if there was frozen water in the Cabeus crater on the dark side of the moon. They crashed the probe into the moon, and the mission was a total success. Yes, there's water on the moon. Also, during the Cold War in 1962, the US launched Project Starfish, the largest nuclear detonation ever carried out in space. It was a high-altitude test that caused a massive electromagnetic pulse so strong that it messed up the very instruments meant to measure it. It even affected Hawaii, causing about 300 streetlights to go out, triggering burglar alarms and damaging phone lines. Now you know who and why someone wanted to nuke our dear satellite. But as it turns out, we couldn't change the moon's orbit or get a fireworks show that easily. The moon's too massive and the consequences are way too dangerous. But hey, it's all just a cold case now, right? There's no one still trying to prove who's bigger and stronger by nuking stuff. Right. Let us know in the comments if you already knew about this case, and until next time.
What if our moon was hollow? Would we be able to hide inside in case some terrible catastrophe destroyed our home planet? Well, the supporters of the hollow moon theory believe that it's actually a real option. The hollow moon is a hypothesis claiming that Earth's moon is either completely hollow or has quite a lot of place inside. The thing is, the moon is less dense than Earth, and it seems to support the idea of its hollowness. But according to science, the reason is the fact that Earth's upper mantle and crust are less dense than the heavy iron core of our planet. Then, there's also the claim that the moon rings like a bell. For almost a decade, between 1969 and 1977, seismometers installed on the moon by the Apollo missions kept recording moonquakes. The moon was reported to be ringing like a bell during such quakes, especially shallow ones. On the 20th of November, 1969, Apollo 12 deliberately crashed the ascent stage of its lunar module into the surface of our natural satellite. According to NASA, after that, the ringing continued for almost an hour. This made some people argue that the moon must be hollow like a bell. Later, lunar seismology researched those shallow moonquakes and showed that they acted differently than quakes on our planet, mostly due to differences in type, texture, and density of the lunar and Earth's rock layers. The speed of sound waves in solids is determined by the medium's compressibility and density. No one has ever found any evidence of a large empty space inside the moon. And still, in 1970, Michael Vassin and Alexander Sherbakov suggested a hypothesis that the moon could be a spaceship designed by mysterious extraterrestrial beings. In 1965, writer Isaac Asimov made an observation that added fuel to the fire of conspiracy theories. He marveled at the sheer astronomical accident that the moon fits so snugly over the sun during total eclipses. The sun's greater distance makes up for the incomparably larger size of the star. As a result, it seems to us that the moon and the sun are the same size. The author added that there was no astronomical reason why the sun and the moon should fit so well. So since the 1970s, conspiracy theorists have been quoting Asimov's words about solar eclipses as evidence of the artificial origin of the moon. Mainstream astronomers disagree with such an interpretation, saying that the angular diameters of the moon and the sun don't perfectly match during eclipses. They vary by several percent over time. Many other pieces of evidence confirm that the moon is a solid body that formed after a planetoid crashed into Earth. In the past, scientists thought that the moon appeared after our rapidly spinning planet got rid of a good chunk of its mass. This idea was suggested in 1879 by George Darwin, the son of the very Charles Darwin, the famous biologist. This theory remained popular until the Apollo missions. Then, in 1925, Austrian geologist Otto Ampferer offered another idea, that Earth and the Moon could have formed together from a primordial accretion disk, a rotating disk of dense gas and dust surrounding a young, newly formed star, and used to be a double system. The third theory stated that the Moon could have once been a planetoid caught by the gravity of our planet. The modern explanation usually involves the giant impact hypothesis. According to it, a Mars-sized space body hit Earth and created a debris ring around our planet. In the end, this ring gathered into a single natural satellite, our Moon. But getting back to the hollow moon theory, at the moment, there's no scientific evidence to support this hypothesis. Seismic observations and other data indicate that the Moon has a solid interior with several layers, a thin crust, quite extensive mantle, and a dense core. These days, the idea of the hollow moon is considered to be a conspiracy theory.
There are a few theories about how the Moon appeared in the sky, and recently a new idea has popped up. But before we discuss this newcomer, let's look at the most popular hypotheses of the Moon's formation. The capture theory claims that Earth's natural satellite used to be a wandering body, something like a large asteroid. It had formed somewhere else in the solar system before it was captured by our planet's gravity when passing nearby. The accretion hypothesis suggests that the Moon formed in orbit around Earth at the same time as our planet appeared in the darkness of the cosmos. Then, there's the fission theory that says that at one point in its development, Earth was spinning so fast that some of its material broke away and started to orbit the planet. And the giant impact theory, which is the most popular these days, claims that the Moon formed during a collision between Earth and another hypothetical planet called Theia, which was way smaller, probably the size of Mars. The resulting debris collected in an orbit around Earth and formed the Moon. And now, let's move to the new theory you've been patiently waiting for. According to it, our satellite might have formed immediately, in a matter of hours, after the collision between Earth and Theia. The material from the two planets was likely launched directly into Earth's orbit right after the impact. It formed the Moon and left traces deep inside Earth. In previous scenarios, Theia's remains were thought to have been scattered all over space, mixing with just a bit of the material coming from our own planet. But then, why do we see such shocking similarities between the Moon's and Earth's compositions? Could it be that Theia was isotonically and chemically similar to Earth? Unlikely. But according to the new theory, more material from Earth was used to create the Moon, its outer layers in particular. It might explain this similarity in composition. One more theory also tries to explain this mysterious similarity, the synestia model. According to it, our satellite formed inside a swirl of vaporized rock left by the collision. But this theory can't explain the Moon's current orbit. The new single-stage theory does offer us plausible explanations for both the similarities in composition and the orbit of the Moon. It might also provide us with some answers to previously unsolved mysteries. Since this scenario puts the Moon into a wider orbit and gives it an interior that is not fully molten, it can explain the satellite's tilted orbit and thin crust. In any case, to confirm one of these theories, we need to analyze future lunar samples that will be brought to Earth by NASA's upcoming Artemis missions. Scientists will be able to get their hands on some material from deeper beneath the Moon's surface and compare if real data matches these simulated scenarios. In the past, the Apollo missions already brought back about 1/3 of a ton of rock and soil from our satellite. These samples showed that Earth and the Moon had some remarkable chemical similarities. They could only suggest one thing. These space objects had a linked history. If the Moon had formed elsewhere and been captured by our planet's gravity later on, its composition would be very different from that of Earth. But if the Moon had been created at the same time as Earth, or if it had broken off our planet, the type and proportion of minerals on the Moon would be the same as on Earth. But they are a bit different. The Moon's minerals contain less water than their terrestrial counterparts. The satellite is also richer in materials that form rapidly at high temperatures. That's why the most accepted model of the Moon's formation these days is the giant impact model. Meteorites coming from the moon are a great source of data for studying the origins of our satellite, too. They can tell us even more about the moon than Apollo samples, all because such meteorites come from all over the surface of the moon. Meanwhile, Apollo samples were collected just in one place near the equator, on the near side of the moon.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin, and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the moon don't contain water, but that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
What the? Look! Do you see this? Part of the sun has broken off, and it's now churning above the star's surface, having formed a giant vortex. What's going on there? Well, let's admit it. We still know very little about the sun, however crucial this star is for our well-being. But in the case of the broken sun, scientists can probably explain what happened. Some of the star's plasma likely erupted from the sun's surface and broke away, creating something resembling a crown-like vortex over the solar North Pole. And still, this is just a theory. Astronomers need to conduct further analysis to figure out if this is what really happened. At the moment, they're a bit baffled, since this phenomenon is nothing like anything they've seen before. But the footage we've got is undeniably impressive. What is more alarming, though, is that the behavior of our star is currently changing. The sun is ramping up its activity. It's getting rowdier with flares and sunspots. This year, it's flared every day so far. It's also thrown up a few X-class and M-class flares in January of 2023. These flares are the largest and second largest eruptions our star can produce. Even though it sounds kind of alarming, don't worry. The sun has certain activity cycles that repeat every 11 years or so. Some of them are relatively calm, while others are absolutely wild. These cycles happen simultaneously with the fluctuations in the sun's magnetic field. When it gets the weakest at the star's poles, they switch places. This makes the polarity of the magnetic field reverse. This is the very period of time when the sun is the most active. It's known as solar maximum. Right now, we're near this solar maximum. Scientists can figure it out by analyzing unusual solar activity. But since the sun is still pretty much a mystery to us, no one can determine when the polarity reversal is likely to occur. A rough estimation is July of 2025. At the same time, we can't say that the current solar situation is normal. It's true that each sun's cycle is different from others. Some are weaker and some are more powerful. So this one, which started in December of 2019, has already significantly exceeded all scientists' expectations and keeps doing so. Which brings us back to the vortex observed on February 2nd, 2023 that impressed astronomers so much. It started as a solar prominence. This is a bright plasma filament extending away from the surface of the sun. And, let me tell you, solar prominences are an absolutely regular phenomenon. And like the most recent one, they often occur at high altitudes around the sun's crown, which is the outermost layer of the star's atmosphere, also known as the corona. Anyway, prominences like the one in question are called hedgerow prominences because they look like a hedge. But what surprised astronomers happened a bit later. The material of the filament apparently broke away and started circling the pole near where it occurred at 60 degrees latitude and at a speed of about 60 miles per second. And it lasted for about 8 hours. One scientist, who has been observing the sun's cycles for decades, claims that he has never seen vortices like that. Unfortunately, solar poles are very difficult to observe, so it might be a while till we get our answers. For the first time, a spacecraft touched the surface of the sun in 2021. It was NASA's Parker Solar Probe that flew through our star's upper atmosphere. It also took some samples of particles and examined magnetic fields there. It was a real milestone and a giant leap for solar science. Getting their hands on the very stuff the sun is made of will allow researchers to uncover crucial information about our star and its influence on us and the entire solar system. The Parker Solar Probe moved closer to the sun's surface and started making discoveries that other spacecraft were too far away to see. For example, the probe examined the solar wind from within. It's a flow of particles coming from the sun. These particles can influence us here on Earth. Even before coming super close to the star, the Parker probe found out that near the sun, there were loads of magnetic zigzag structures in the solar wind called switchbacks. But at that time, scientists couldn't figure out how they formed and where they appeared. But now, more than 2 years later, we know for sure that switchbacks originate at the solar surface. As you know, the sun doesn't have any solid surface, unlike our planet, but it has a superheated atmosphere, which is made of solar material bound by magnetic forces and gravity. When pressure and rising heat push that material away from the star, it eventually reaches a point where the sun's magnetic field and its gravity can't contain it anymore. This point has its own name, the Alphane critical surface. It marks the edge of the solar atmosphere, and that's also where the solar wind begins. The material that manages to make it past the boundary turns into the solar wind. it drags the sun's magnetic field toward Earth and beyond. But the most important thing is that past the boundary, this wind starts moving so fast that its waves can't return back to the sun, which literally means severing all connections with the star. During its flyby, the Parker probe passed inside and out of the sun's corona several times, which proved that the Alphane critical surface wasn't shaped like a smooth sphere. It has valleys and spikes, and its surface is kinda wrinkled. At one point, the probe even came across a pseudo-streamer. These are massive structures in the sun's corona that rise high above the surface of the star. You can see them from Earth during solar eclipses. And you know what? For the Parker probe, passing through the pseudo-streamer was like flying into the eye of a storm. Inside, everything was much quieter. Particles moved more slowly, and there were fewer switchbacks. It was a huge change from the barrage of particles the probe encountered inside the solar wind. Now, speaking of solar flares, those are pretty dangerous for Earth. The radiation they release can interfere with our radio communication. Such storms affect all electronic systems, from the internet to power grids, and can even destroy satellites. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares that people should be worried about. They cause the strongest and longest-lasting solar storms. A super strong solar storm heading toward Earth won't happen at once. First, there will be high-energy sunlight, mostly ultraviolet rays and X-rays. They will ionize our planet's upper atmosphere and mess up radio communication. After that, a radiation storm will hit Earth. And finally, a colossal cloud of charged solar particles will reach our atmosphere. The particles will interact with the planet's magnetic field and wreak havoc all over the world. If an intense solar storm happened these days, it would start by disrupting GPS and knocking out satellites. If any astronauts were spacewalking at that moment, they would have mere minutes after the first flash of light to find shelter. Their spacecraft would likely be properly shielded and safe enough. The main challenge would be to get inside in time. After that, the storm will proceed to interfere with satellite communications. That's why tons of your daily activities, from calling your friends to paying with your credit card, would be at risk. But one of the worst consequences would be connected with power grids. Power surges caused by the particles coming from the sun would damage giant transformers. A powerful solar storm could cost people $1 trillion to $2 trillion. Luckily, if such a powerful solar storm was heading our way, we'd most likely get some kind of warning. Modern equipment all over the world and in space doesn't stop watching the sun even for a second. It would give us some time to prepare, between several hours and a couple of days. And if transformers were taken offline in time, the consequences wouldn't be so dramatic.
Attention! Attention! Emergency alert! This is not a drill. The Milky Way is on fire. I repeat, the Milky Way is on fire. Evacuation protocols activated. All terrestrial life forms are to be moved to the Andromeda Galaxy immediately. I repeat. Wait, a fire in our home galaxy? It all comes down to the incredibly hot gas surrounding the Milky Way. This isn't just intensely hot, it's also existed for billions of years. But what's heating this gas and keeping it that way? The Milky Way holds far more gas than stars, and this gas is crucial for forming new stars. Over billions of years, this massive reservoir has allowed the galaxy to keep producing stars. But this gas is incredibly thin and spread out, which makes it next to impossible to observe it directly. For a long time, this made it difficult to figure out how much gas the Milky Way really contains. But in recent decades, researchers finally confirmed that the galaxy is indeed surrounded by an enormous sphere of hot gas. This gas cloud extends as far as 700,000 light-years from the galaxy's center and reaches temperatures of several million degrees. At first, scientists thought the gas's insane temperature was due to the Milky Way's gravity. They believed that gravity caused the gas to swirl around, keeping it from falling inward and heating it up in the process. But then, recently, scientists have discovered something even more surprising: a second layer of gas. And it's even hotter. How did we discover this gas with a temperature of around 18 million degrees Fahrenheit? Faint X-rays coming from all directions in the sky revealed the presence of this gas. The gas also showed up as it absorbed light from distant quasars, bright objects far outside of our galaxy. No wonder scientists began looking for the sources of heat that could explain this bizarre phenomenon. They soon found that the two types of gas, the X-ray emitting gas and the absorbing gas, came from different regions in the galaxy. The X-ray emitting gas is apparently produced by a puffed-up region around the Milky Way's stellar disk. This region is a direct result of the galaxy's star formation, which is still going on. Massive stars in these regions eventually explode as supernovae, releasing huge amounts of energy. This energy heats the surrounding gas to extreme temperatures. The gas heated by supernovae becomes turbulent, moving around chaotically. Some of it escapes into the space around the galaxy, while some of it cools down and falls back toward the disk. This continuous cycle of heating, cooling, and movement keeps the hot gas layer visible in X-rays. The absorbing gas is enriched with elements like sulfur, magnesium, and neon. These elements are created inside massive stars through nuclear reactions and escape into space during supernovae explosions. Runaway stars that are flung out of the Milky Way's disk also contribute to this process. When they explode as supernovae, they create pockets of enriched gas above the galaxy's disk. The X-ray emitting gas forms a glowing layer around the Milky Way's disk. This layer never disappears due to the star formation and supernova activity happening in the galaxy. Together, these processes explain both the absorbing and emitting signals observed by astronomers. Star formation, supernova explosions, and gas movement all work together to shape the Milky Way. The hot gas not only helps regulate star formation, but also redistributes materials created inside stars. And elements produced in stellar cores are spread throughout the galaxy by supernovae, becoming the building blocks for future generations of stars. The research team plans to keep observing the gas at other wavelengths of light. This might give us even more information about how the gas behaves and what it's made of. And once we understand the dynamics of this gas, we're likely to learn more about how galaxies like the Milky Way evolve over time. We need all the data we can collect after all. We don't even know the true shape of our galaxy yet. Recent discoveries have revealed that the Milky Way is not a flat disk as previously thought. No, it has a warped structure. And the craziest thing? Dark matter might be the cause of this deformation. The first confirmation that the Milky Way isn't a perfectly flat disk came from observations by the Gaia spacecraft. Gaia mapped the positions and movements of over 1 billion stars, and its observations showed that the Milky Way extends farther outward than initially believed. At its edges, the galactic disk was a wavy, warped structure with serious deformations along the outer edge. But what causes the warp? These deformations may result from ancient galactic collisions, like the Milky Way's collision with the Sagittarius dwarf galaxy around 6 billion years ago. However, a new study suggests another possibility. The warp might be caused by a tilted dark matter halo surrounding our galaxy. Dark matter halos are invisible, yet massive structures surrounding most galaxies, including the Milky Way. These halos contain most of a galaxy's mass and have a strong gravitational influence on the galaxy's structure. If a dark matter halo is tilted relative to a galaxy's plane, its gravitational effects could distort the galaxy over time. To figure out whether this theory is true, Researchers used data from highly detailed computer simulations that modeled galactic evolution, seasoning the process with dark matter and interactions between matter and magnetic fields. The analysis revealed that the inner region of a dark matter halo can indeed tilt significantly with respect to a galaxy's plane. This tilt could result from galactic collisions or close encounters with other galaxies. Such crooked halos can stay this way for billions of years, which is long enough to warp the galactic disk. At the same time, this phenomenon isn't something unique. Astronomers have observed warped planes in other galaxies as well. In fact, nearly half of all spiral galaxies in the universe have warped disks. So, tilted dark matter halos and their gravitational effects might play a widespread role in shaping galaxies over time. While we're looking for answers, the Milky Way continues to shine brightly. But what kind of space electricity keeps its lights on? What fuels the process of star formation? After all, roughly one sun-sized star is born each year in the galaxy, and it needs a lot of fuel. Star formation requires hydrogen, the most abundant element in the universe. But it would still have been depleted long ago, unless there were a replenishing source. The source might be fast-moving hydrogen clouds raining down into the galaxy's disk. The hydrogen fueling the Milky Way is ionized, making it challenging to detect. Unlike atomic hydrogen, which emits light, ionized hydrogen does not. Instead, it absorbs light, which means it can only be observed when it passes in front of a bright background source. Before, astronomers used quasars, extremely bright distant space objects, as backlighting to detect these gas clouds. Unfortunately, in this case, it was impossible to determine how far away the clouds were. They could have been located anywhere between the Milky Way and the quasars billions of light years away. To pinpoint the location of the gas clouds, astronomers turned to the cosmic origin spectrograph aboard the Hubble Space Telescope. They observed 27 stars located within 10,000 light-years of the Milky Way's disk. They analyzed the stars' light and found that about half of the stars were obscured by gas clouds. It means they were close enough to directly feed the Milky Way's disk. The researchers calculated that the gas clouds contained a total mass equivalent to a whopping 110 million suns. This vast reservoir of hydrogen offers more than enough fuel to sustain the Milky Way's star formation. But where did those clouds come from? So far, it still remains a mystery. There are two main possibilities. The cloud might consist of hydrogen formed shortly after the Big Bang, primordial gas. These structures could have remained outside any galaxy for billions of years, only recently falling into the Milky Way's gravitational pull. Or the clouds might be made of material ejected from the Milky Way itself. When stars explode as supernovae, they can blow gas outward. Over time, this material could cool and fall back toward the disk, forming the clouds. We'll be able to figure out the origin of the clouds only after studying their chemical makeup. Gas from exploding stars contain heavier elements, while primordial gas created after the Big Bang is composed almost entirely of hydrogen and helium. Future ultraviolet telescopes could provide the detailed measurements needed to settle the question. Look at this comet! Recently, it's erupted 4 times in less than 48 hours and has become nearly 300 times brighter than normal. This is the most powerful set of eruptions the comet has had in over 3 years. Should we worry here on Earth? Well, I wouldn't say scientists are worried. They're super excited. First, let me give you a little background. 29P is what astronomers call a Centaur comet. Those are icy objects that orbit the Sun in the space between Jupiter and Neptune. What's interesting about centaurs is that they're kind of like cosmic hybrids because they're moving from one kind of space body to another. They start their life as far-out objects in a lifeless, freezing cold zone beyond Neptune. But then, over a few million years, they move inward toward the Sun because the planets of the solar system affect them with their gravity. Eventually, they turn into short-period comets. This term means they can pass close to the sun and then slingshot back out into those icy regions. Centaurs, and their name indeed comes from a hybrid half-horse, half-human creature popular in Greek mythology, are especially interesting because they're basically leftovers from the formation of our solar system, kind of like cosmic fossils. Since they've been hanging out in the frigid outer solar system for so long, they've kept a lot of the volatile materials that were present when the solar system was first forming. This makes them a valuable clue in understanding how our solar system evolved. That's what makes scientists so enthusiastic. Now, about 29P itself. This thing is huge for a comet. It's about 37 miles across, which is almost 3 times the length of Manhattan. Now, worry not, it's too far away to cause us any harm. While it's one of up to 1,000 known centaurs, 29P is also in a rarer group of comets called cryovolcanic comets. Those are a fascinating class of space objects that have unique geological activity. The thing is, cryovolcanic comets not only contain a unique mix of ice, dust, and rock, but also feature cryovolcanoes, aka cold volcanoes. They erupt with volatile materials like water, ammonia, or methane instead of molten rock. As for regular comets, when they approach the sun, the heat from the star evaporates their gases, leading to the emissions of dust and tiny particles, electrons, and ions. These materials create those magnificent trails. These eruptions are incredibly spectacular and make the comet appear a lot brighter since the cloud of cryomagma reflects the sun's light. The cloud that forms around the comet is called the coma, and it can grow so large and bright that it makes the comet look like a fuzzy ball of light. If you've ever observed a comet, the coma is the halo you see around it. Such eruptions are pretty unpredictable. While most cryovolcanic comets follow elliptical orbits that take them far out into the solar system, 29P is on a more circular orbit, staying around the same distance from the Sun as Jupiter. You'd think that this would mean its eruptions would be more regular, but that's not the case at all. In fact, 29P erupts in a completely random and unpredictable way, and scientists are still trying to figure out why. The latest outbursts started on November 2nd, 2024, when 29P erupted for the first time in almost 2 years. This was followed by 3 more large eruptions in less than 48 hours, which really got the attention of astronomers at the British Astronomical Association. They'd been tracking 29P for a while, and they reported that the eruptions sent out a cloud of debris reflecting about 289 times more light than the comet's nucleus, which is a huge increase in brightness. Astronomers are expecting that the coma, which is growing after each eruption, could take on an unusual shape. The multiple outbursts might cause the coma to expand in a weird, irregular way. This is especially interesting because 29P hasn't had a major eruption like this since November 2022. Then it threw out over 1 million tons of debris. The last time it had a massive outburst was in September 2021, when the comet had multiple eruptions in quick succession. In addition to the confusion about its eruptions, 29P is pretty different from most other comets. Most comets have elliptical orbits that take them far out into the solar system. They spend decades, centuries, or even thousands of years far from the sun, only to erupt when they get close. But 29P doesn't do that. No, it orbits the sun once every 15 years and stays at about the same distance as Jupiter. This strange behavior makes astronomers even more eager to figure out what's going on with it. Another cool thing about 29P is that it doesn't ever get close enough to the sun to grow a tail like other famous comets, such as the once-in-a-century comet, Tsuchinshan Atlas, which has recently made headlines. It passed the closest to Earth in 80,000 years. NASA's James Webb Space Telescope has been keeping an eye on 29P, helping solve some of the mysteries about the comet. And it has recently made another groundbreaking discovery. It has detected jets of CO2, good old carbon dioxide, coming from the comet. This was the first ever detection of CO2 jets on this particular comet. Webb has also discovered a jet of carbon monoxide coming from the comet. It can tell us a lot about the composition of the comet and its outbursts. What's especially interesting is that the jets seem to come from different parts of 29P's nucleus. Even though Webb can't actually figure out the nucleus itself because it's too small to see in detail, the jets coming from different locations on the comet's surface suggest that the nucleus may be made up of multiple objects. These objects might have different compositions, and it's possible that the nucleus is more of a composite body made up of smaller chunks that came together over time. Strangely, astronomers haven't detected any water vapor in the comet's atmosphere. That's unusual because the atmospheres of most comets often contain water. Our comet might lack water vapor due to the extremely cold temperatures on its surface. It could prevent water from evaporating or vaporizing. 29P isn't the only thing that Webb is studying. The telescope has also been making some big discoveries about galaxies far, far away. For example, Webb has recently spotted a galaxy with a pretty complicated name which appeared about 1 billion years after the Big Bang. What's super weird about this galaxy is that the gas in it is shining brighter than the stars, which is really rare. This could be a missing link phase in the evolution of galaxies, something that could help astronomers understand how galaxies transitioned from the very first stars, called population 3 stars, to the types of galaxies we see today. The stars in this galaxy are much hotter than we see in modern galaxies in local universe, around 144,000 degrees Fahrenheit, compared to the typical 72,000 to 90,000 degree Fahrenheit of stars today. This could mean that the galaxy is in the middle of a super brief but intense phase of star formation, where huge, hot stars are popping up in a dense gas cloud. And this gas cloud is glowing so brightly because it's being hit with tons of light from these stars. The research team behind this discovery says that although the galaxy doesn't have population 3 stars, because the data shows it has too much chemical complexity, it still could be a guide for understanding how galaxies evolved, from the first stars to the galaxies we're familiar with today. There are still so many questions about this galaxy. Is it a rare phase, or is it something that happens often in the early stages of galaxy formation? Astronomers are hoping to study more galaxies like this one to figure it out.